Hello, welcome to my channel. In this video, we will discuss about the laboratory thermometer and some other important topics also. Already we have discussed about the clinical thermometer. If you are not saw that video means watch that. I have given its link in the description box. This is the laboratory thermometer. The temperature shown in this also read by the same method as we did in the clinical thermometer. Here also we can calculate the measure of one division by using the same method as we did in that clinical thermometer. The range of laboratory thermometer is -10 to -10 degrees Celsius to 110 degrees Celsius, because the objects around us are at the any temperature. So to measure the temperature of those objects, this laboratory thermometer is designed as its temperature range is between -10 degrees Celsius to 110 degrees Celsius. Take some hot water in the beaker. Now dip the laboratory thermometer in that water so that the bulb of the thermometer does not touch to the bottom of bottom of beaker and also side of the beaker. Now observe the movement of mercury inside the thermometer. It moves up and slowly comes to rest after some time. Now note down that reading. That is the temperature of that hot water at that time. Hello. Here we are taking the reading by keeping the thermometer into the water itself. If you remove that from the beaker to note down the reading means the mercury level slowly comes down. Then we can't take the exact temperature or reading. But in case of clinical thermometer, we remove the thermometer from the mouth and note the reading. Then why not to remove the laboratory thermometer from the substance of which we measure the temperature, like this clinical thermometer? Yes, before to know about that, please subscribe to my channel and hit the bell icon which is outside, and also like and share. In clinical thermometer there is a structure called kink or constriction. Because of this structure, mercury level does not fall down on its own. That's why we give jerks to the clinical thermometer so that all the mercury level settles down. Next, we discuss about some interesting topics which we come across in our daily life. When we keep a frying pan on a stove, what happens? It becomes hot. When you keep that hot frying pan on a cool surface, after some time it becomes cool. Slowly that hot pan became cool because heat transferred from that pan to surroundings. Here also heat transferred from stove to pan. In general, what we can say is heat transfers from hotter body to a colder body. Then how heat flows from hotter body to a colder body? For that, we'll observe one experiment here. The experimental setup is like this. Take a metal strip of aluminium or iron, fix it to a stand, or you can keep in between two bricks. Then attach small pieces of waxes along the metal strips, considerably smaller distances. Then keep a candle at the other end of the metal strip. When you start heating the metal strip with the help of the candle, the wax piece which is near to the candle falls down first. Then slowly other wax pieces starts to fall down as you heat it. When we heat the metal strip with the candle, the end which is near to the candle becomes hot first. Okay, so that the piece of wax falls down at there only. Then it slowly flows towards the other end of the metal strip. But you may observe that we can easily hold a holder of a hot pan without any sensation of heat. Then why heat has not flowed up to there? That is because there are some materials in nature, they do not pass the heat through them easily. They are called insulators. For examples, plastics and wood. They does not pass the heat through them easily. They are called insulators. And the materials which allow the heat to pass them are called conductors. Examples, aluminium and iron. Water and air also poor conductors of heat. To know more about that, we'll do one experiment. Take a round bottom flask, keep it on a tripod stand and add some water into that flask. Now start heating with the help of a bunsen, or you can take a candle also. When you continue the heating, the water near the flame becomes hot and starts to rise up. The cold water from the sides move towards the heater and take place of the previous water. After some time, that also becomes hot and rises up. Again, cold water from the side moves towards the heater. This process continues up to whole water becomes hot. So, this mode of heat transfer is known as convection. This is known as convection. Air is also a poor conductor of heat. That also we know with the help of a small experiment. Keep a candle, hold your hand at the top of the candle at the safe distance and other end at the side of the candle. Now after some time, which hand you are feeling hotter? Certainly the hand which is at the top. The hand which is at the side of the candle feels little cooler than that of the hand which is at top. Here also the air near to the candle heats first and rises up, and the side cool air comes to its place, so that air also get heats by the convection method. In coastal areas, the land becomes hotter than that of the water. So, the hot air from the land moves up. Okay. To the place of that, the cool air from the sea comes and occupy that place. So in the daytime, the peoples near the sea, that in the coastal areas, feels cool. Again, this process is due to the convection. But in the night time, the water becomes cool slowly. All the cool air from the land move towards the sea. When all the cool air move towards the sea, the people who are near to that sea feels very hotter. Okay, so the air from the land to which moves towards the sea, that is known as land bridge, and in the daytime the sea air moves towards the land, and that is known as sea bridge. That's why the peoples who are live in the coastal areas feels cool in the daytime and hot in the night time. That's all because of convection of air. When we come out in the sun, we feel warm. Here, how the heat is transferred from sun to us. This is not by conduction or convection method, because those two methods need a media. As we go above from the earth, there is no air media. So, here heat transfers from another process called radiation. Transfer of heat from the radiation does not require any medium. Our body also gives heat to the surroundings and receives heat from it by radiation. All the hot bodies radiates heat. When heat falls on an object, some amount of heat get reflects and some amount of heat get absorbed and some amount of the heat transfers. This you might have experienced that when you are going with the umbrella under the sun, at first you will not feel anything, but as you move on, you will feel little heater. This is why, because when sun falls on the umbrella, some of the heat get reflected back and some of the heat absorbed by the umbrella and some of the heat transferred to the umbrella as another form of energy. So we feel little heat after some time. This picture gives a clear idea about all these three. The sun heats the ground by the radiation process, and the ground heats the air by conduction method, and the warm air rises by convection method. So this is all about the conduction, convection and radiation. And if you have any doubt or the question, please comment below, and thank you.